So this is the calculus, differential calculus. It's a topic which comes in paper 1 and paper 2. So this is under differential calculus. There are two types. There's integral calculus and differential calculus. This one is differential. So now how do we differentiate from the first principles? When they say differentiate a function, this is a function, from the first principles, how do we go about it? So this is what you have to do. Function prime limit h tends towards a 0 h, then here we write f x plus h minus f x minus f of x. See that? So limit h tends towards a 0, limit h tends towards a 0, f plus x, x plus h in brackets, and then minus f of x over h, like that. So this is a symbol for differentiation as well. We call it prime. It's another notation for differentiation. So now what we have to do here is to replace the function into this. See that? So as you can see, this one, you get the concept under functions. You need to replace. You need to replace where there's x here, you put x plus h. So let us replace. Where there's x, we put x plus h. So we do it. Then there will be minus 2. Remember, where there's x, we had to put x plus h. So it will be x plus h squared, because x plus h represents this x, as you can see. Then there's minus 2 there. Minus, this one is a function. This function, f of x is equal to, so just write it the way it is, which is x squared minus 2. Now since there are 2, we'll put this in brackets over h. Remember, limit h tends towards a 0. They are talking about this h. This, what you are seeing here, is talking about this h. It means this h is going towards a 0. So at a certain point, whatever will be with h won't be considered. So let's see how we can go about it. So next, we write, how do we expand this? This one, in simple terms, if you want, you can do x plus h times x plus h as well, or in simple terms, you just do x squared, then you multiply as if they are in one line, like 2 times x times h, it will be 2xh. Then this h also you square it to be like that. It means minus 2 has remained. See that? So what about here? Here is just to multiply the negative times everything inside. So it will be negative x squared plus 2. Negative times positive, negative, negative times negative, positive, over h. You see that? So you have to do like that. So what we're going to do is to continue writing this. So if we were to group like terms here, if we were to group like terms, x squared and minus x squared, they can cancel. X squared and the negative x squared, they will cancel. Also a negative 2 and a plus 2, they can cancel if we were to group them. So it means you have remained with 2xh plus h squared. So next step, This is what you have to do. Next step, you need to do this. You factorize just an h. Just factorize an h, so h is common. Always just factorize h, don't factorize a number. So if h is common, it means here there will be 2x remaining. And here, since there were 2, it was h squared, and we have h outside, it means only h has remained over h. So even here, as you can see, we have h and h, you cancel them, right? You cancel them. So limit h tends towards a 0, then 2x plus h, like this. So limit h tends towards a 0. It means h is becoming too small to be considered. H is becoming too small to be considered. So it means wherever there is h, we won't include it. The one with h, we won't include it. So it means, as you can see here, this h won't be included because h is becoming too small or is going towards a 0 to be considered. So the answer will be just 2x. This one won't go because look at this. This is talking about this h, to say this h is becoming too small to be considered. So just write whatever doesn't have x, which is 2x. That is your answer. So this is how you factorize, this is how you find the differentiation from the first principles. So this is what you're supposed to do.